So I'm going to cover a particular challenge that I've seen. I'll go back to the main slide here. I'm working in a lot of enterprise organizations, and the one I just rolled off was a Fortune 40 home improvement company. And environments are really challenging for that organization. So I'm going to talk a little about that, talk about some technologies and capabilities that we are starting to see leach into the enterprises as well as in the smaller startups that have been adopting and leveraging already. And that leverages containerization. So in terms of introduction, we're here at the SmartBear conference, so we're talking about test automation as an example, but we're also talking about API design practices. There's a theme that's behind a lot of the SmartBear tooling, which is incorporation into CI/CD, automation of environments, automation of tests. So that's kind of a theme that I'm going to talk a little bit about. And when I do the demo later on, I'll be doing some stuff manually so you can visually see it, but you'll be able to easily see how it could be part of a Jenkins job, or it could be part of Bamboo, or whatever tool sets that you decide to use. So the challenges that we see, so this Fortune 40 organization was doing an Agile transformation, a cloud transformation, and DevOps transformation at the same time, which I think is insane, because usually one of those is hard enough and takes years to do properly. But that's what they were going through. So during that work, I was bouncing around between setting up DevOps, helping with their infrastructure automation strategy, and then helping them with their API design standards, and trying to educate them on how to build microservices. So various groups, techie people, engineers that don't know how to code, that do a lot of SSH, and then people that are more business-oriented and trying to align those. So with Agile, we know we're getting a lot of releases that are coming. And if you're not doing Agile right now, then every 2 weeks, you're supposed to prove that you have something working, right? That's the manifesto, if you're following it. Microservices, so Martin Fowler kind of coined this phrase and looked at, if you're not familiar with Martin Fowler, he's kind of the father or grandfather of CI with cruise control. Anybody know cruise control? I've heard of it. It doesn't get used that much anymore, but he's a very significant voice in the community on all things microservices. And really it's around making your software smaller and smaller and smaller so that it really can't be made any smaller. And we have to release that thing as frequently as Agile is telling us to. So we have smaller software, more releases, and if we're trying to resolve a big business process, we need a lot of little pieces of software to do that. So we're releasing a lot of stuff out the door. How do we potentially resolve some of that? Well, there's technologies such as containers. If you haven't heard of containers, you may have heard of a company called Docker that's become pretty prevalent over the past few years. We'll talk about what that is. There's another technology on top of that. Containers on their own are pretty good, but they're not production quality. So there's a technology that was built by Google based on their many years of running containers that they've open sourced called Kubernetes. And if you haven't heard of Kubernetes, then you probably have been in a closet someplace. It is everywhere. Other than microservices, those are probably the top two things that people are talking about. From SmartBear perspective, I taught a class briefly yesterday about Service V and service virtualization. And then there's test automation, right? So we've got the ReadyAPI suite. And all these tools are enabling API testing or microservices testing, API or microservices simulation or emulation. So we can take advantage of those tools as part of our strategy. How many people in this audience have a team devoted to release management? Is anybody? There's got to be some. So there's usually a release management team, and typically they're the ones that own the schedule. The schedule being which environment gets what piece of software at what time, what's the time window that you have. So this is the experience that I've seen at fin services companies like Citibank. This company mentioned the Fortune 40 company, and there's a guy that literally has a spreadsheet that says you're slotted for this time. And you're dependent upon this, so they're going to go ahead of you, and you're going to go behind them, and then the next person comes along, right? It's a very challenging scenario. And what that really means is that effectively, if you're not from the area, and you've never driven 128 in the morning, or 495, or the Mass Pike, then you're effectively sitting in gridlock. And that's what happens in a lot of these enterprise organizations is they can't get the software out the door fast enough because they haven't automated their infrastructure, they haven't automated their releases, they haven't automated their tests. Automation is a key component to speeding that up, to effectively freeing that up. We saw that earlier with the Intel speaker that spoke of kind of doing parallelism in development and kind of opening up the freeway. This is another variation of that. So I'm going to call the old world static environments, environments that are effectively curated and maintained. They're configured by administrators or maintained by administrators. You want to change something on the box, you got to put in a ticket. Is that something you guys are familiar with? Is that something you experience? Okay. The new world is the opposite of that. The new world is this notion of dynamic environments. So effectively, infrastructure is no longer static. Sometimes you'll hear pet versus cattle. Pet is maintaining an existing system and you kind of taking care of it, like my little dog Gizmo. I take care of it, he continues to grow, I take him to the vet. You know, he's there, he doesn't change that much. He can't do more than a few things, right? The world is moving more towards this notion of kill it, it's cattle. And it's a kind of a bad analogy, but you create something that has a particular view of what you want at that time, you run it, and then you kill it. So there's this pet versus cattle notion, you'll hear of that when it comes to containers. So to do these dynamic environments, we have to use certain technologies that help support that. The current technologies that help support that are containerization technologies such as Docker, infrastructure on demand. This could be public cloud, private cloud. I'm going to be focusing on Kubernetes. This is a type of technology that manages my containers and keeps them running appropriately. Another theme that we're seeing a lot is open source software. A lot of companies are ditching, this is a good place because SmartBear is an open source provider, right? We're providing tools that are available for you to contribute and participate in. But we're starting to see more on the operating system level, the testing level, framework level. A lot of open source components are being leveraged, probably over the past 5 to 6 years at a minimum. Container orchestration, I mentioned Kubernetes, again. Swarm, that's from Docker. Mesos is from Apache. And then service virtualization, that's the Service Suite product I mentioned earlier. So these are different things when combined together that can help us create environments on demand. And then when we're done, what do? We kill them, right? So you literally load up everything you need to do those tests, and then you destroy them. So create and destroy paradigm is what the smaller companies are doing quite effectively. So really, what does that mean? Well, what's the value of that? Well, that means that any team at any time can get their environment. Right, so now we're not limited by the schedule, the spreadsheet, the particular person that owns the release management team. We're able to effectively create and destroy what we need at any time. Go ahead.
I would think you'd still have to have that environment ran by somebody that says, yes, this is the correct environment.
Yeah, it's a great question. Yeah, so
Can you just repeat the question?
Sorry. Yeah,
so
the question that's being asked is I think you would need to have somebody that manages that environment, right?
Yeah, or approves it and says, yes,
right.
This is the proper environment.
So the idea here is with environments is that instead of them being curated and maintained by people via keyboards, you codify it. So effectively, when you create an application, you may have a React front end, you may have a series of APIs, and you have a database. So in the new world, we actually codify what the database structure looks like, where the data comes from, how we load it, how we set it up to a base state. We codify the API layer, what it looks like, what the base state is. We codify the front-end infrastructure for the web application. Those have to be synchronized, right? So the responsibility of the teams is not only the code, but now the infrastructure, and that's called infrastructure automation. So you could be using Ansible. I'm using Docker files, so it's an alternative approach. But I can codify exactly what I need so that it can be spun up and deployed anywhere at any time and have the same exact experience. So that's the difference. So dynamic environments, sounds great and sounds easy, it isn't, right? The key component here is that as development teams are built out, as you build products, infrastructure automation is going to be just as important as test automation, is just as important as the actual source code itself. And they work together in lockstep, right? Is anybody doing any kind of infrastructure automation right now? I don't know if you are or not, or.
Well, not really, but there's definitely some challenges depending on the product because we're multi-product. And I think it's more of, some teams work better at making sure they're synchronized.
And synchronized, right.
Yeah, exactly. We're not actually using a tool that does that automation. I think we probably need to.
You're talking to the people component, right? There's people, process, and technology. For today, I'm just talking about there's technology that can help support it, but the people and process components work. Consulting companies and others like myself come in and help organizations mature to that step, where the people are now, hey, I'm just not a system administrator. I'm actually a infrastructure automation engineer. So if you look in the jobs today, you're going to find infrastructure automation as a key component. You're not going to find sysadmins as much because everybody's job is being codified, whether you like it or not. That's where we're going to. And the reason for that is I can repeat and create that infrastructure anytime I need it and have it look identical. And that's a space that's been effectively, at this engineering group within this Fortune 40 company, no one knew how to write codes or scripts. So I was training them how to do that. What is a Docker file? What is this thing called Ansible? How do I program a network? How do I program storage? So those are things that if you've not dealt with the public cloud, if you've never automated, it's coming. And you have to be aware of that, and you have to start preparing for that. Now, this audience, I presume, is mainly people that are focused on SmartBear products, so maybe test automation, QA, et cetera. But we've already had experience on the QA side. Automation is a key component. So, all right. So for people that don't know what a container is, I'm stealing this from Red Hat because Red Hat did a great job of walking through a product I'm going to show of theirs in a little bit called OpenShift, that is Kubernetes. So a container basically is this notion of, on the left-hand side, we get a virtual machine. On the right-hand side, we have a container. In a virtual machine, you get a server, you get the operating system called the host OS. Then you have what's called a hypervisor, and then you have your virtual machine that's running your code, whatever it is. Most people fit onto the left. If you're using VMware, if you're running in Amazon's web services environment or Azure or Google Compute, you're probably in that world. A few years back, we came across, or companies like Docker came about that said, you know what? I'm still going to have a server environment, but I really don't need that hypervisor thing because the operating itself has this notion of being able to separate workloads. So effectively, we took technology that existed already in the Unix operating system, the kernel, and they created something we refer to now as a container. LXC, Docker, these are different options that are there. What it does is it slims down the overall size. So my application could be 10 megabytes, but if I use a virtual machine, it could be 2 gigs, 3 gigs, 5 gigs, 6 gigs in size, very large. So what we're doing here is we're not only providing a way to run and do something similar in virtualization, but we're shrinking the size of it. And that fits very nicely with microservices. We have a small bit of code. We can wrap and define how we want to start it up, shut it down, and we can deploy it anywhere. I can take this code and I can run in Google, Amazon, Azure. It runs identical, right? That's the promise of what Java tried to do many years ago and had some issues with. Another way to look at containers is this notion of developers are building things on the left that are all sorts of odd shapes and sizes. A Python application, a Ruby application, it could be a C++ application. And what we do is we provide a singular representation on the outside that looks identical. And that's where they refer to containers. Similar to the shipping industry, there's a standardized container that everything goes into. So ships just stack them up. They go on a truck. It's well-defined. You know how to put it on things, get it off things. It has doors that open. It's always the same size. You know what you can fit or can't fit inside of that. So the basic idea is going on here. Software goes in of all shapes and sizes, all different interfaces, and then boom, out comes the same thing time and time again. So I can take a container that has Python or Java or other, and I just run it. And when I run it, we say, hey, what things do we want to open up port-wise so we can get into the actual thing inside of it, whatever the application is. So it provides a very simple mechanism to run software. So GitHub, anybody use GitHub in here? That is containered. It is running on Kubernetes. So there are applications of very large scale that are using this technology today. And they've been incrementally working on this for years now. It wasn't an overnight type of thing. So if we look at containers, what are some of the constituent elements that go with it? We've got something called the Docker file. This is the infrastructure automation piece, effectively. I've got to codify what my application requires to run. So I got to write something in a file. When I have that, I can then create an image. I can snapshot at that point in time what those instructions say and create a runnable image. And then once I have that, I can put it someplace that other people can find. This is just like GitHub. For source code, Docker Hub is for images, Docker images. Google and others have their own registries. Once I have that, I can go into a tool like Kubernetes that takes that and makes sure that it runs all the time. It doesn't die. If it does die, it picks it up and puts it in someplace else and makes it very reliable, secure, simplifies the overall deployments. You can do blue-green deployments, canary deployments, things of that nature that are very challenging to do on your own. And then finally, there are platforms in the cloud that you can spin up that support those technologies. So Kubernetes runs in Google, Amazon, it runs on Windows, it runs on Linux, anywhere in containers anywhere at this point in time. So how does this come back to dynamic environments? Well, one thing that's really nice within this technology called Kubernetes that I mentioned that kind of productionizes containers is that I can go ahead and break up environments into something called namespaces. This creates a segregation between workloads within a server in the cloud. So I can create a dev namespace or a QA namespace or UAT namespace. And I can have them running for long term, like you asked earlier. They can be around for a while. But if I don't want to do that, if I want to create and destroy to verify that my infrastructure automation is of quality, just like software, I want to test that and verify it, I can do that too. So I'll show a demo that kind of walks through that scenario. Containers themselves will contain everything I need to run that app. So if you have Java and you're running Java, then you need a JVM inside of it. If I'm running Python, I need different dependencies inside of that. If I'm running a Ruby or Node.js, then I need those type of dependencies inside of it. And that's defined again in that Docker file. So the entire environment, for whatever I need at any time, can be created and can be destroyed. And that's what I'm going to walk through and show you.
Another question?
Sure.
What if they depend on SQL servers and databases and even cross-server databases? Do you have permissions involved? Is that all contained?
So the question that's asked is like if you have databases or other dependencies that are outside of this ecosystem, what you can do is you can create what's called an endpoint. So you can point to traditional infrastructure that's running in your environment or in the cloud or other, as long as it's network addressable. It's called an endpoint. I just set that up. I tell Kubernetes, or in this case OpenShift, here's a database that I'm going to use, and then in my app, it would need to connect to that endpoint. So it provides the capability of a hybrid or a blended style of environment, if you like. Okay. All right, so here's example number one. Namespaces provide the separation. I can have different APIs, and I can have different versions running on the same box. And the system is intelligent enough on how to route requests to version 1.2 or version 1.3 of an API. You have to define your versioning strategy and have it articulate that, but this notion of labels in Kubernetes allows you to route things accordingly. So I can have a default namespace, or I can have a dev namespace that's integrated dev as an example, and then I can have QA farther down the right. And I can use labels to further categorize, hey, this is a dev instance or a dev API versus a QA API. And by providing that characterization, that metadata, it allows things to get routed appropriately. So when requests come in, you say, I want to go to QA in version v1, it goes to QA v1. And you don't know where it's going, you just know you're going to get there. If you can't, because the thing is down, then you'll get a traditional error response back. So this is one way to separate your infrastructure. Each of these are Docker images that are running, but in different namespaces, and they can't interact with one another. They're treated as separate environments in effect.
Mm-hmm. Still, for a given environment, is it one database or different databases? Based on
it's up to you. So if you containerize the database, you would snapshot the database with all the details. If you don't containerize the database and the database is externalized, you may have multiple databases that have different schemas, or you may decide to organize it however, whatever Oracle or MySQL provides to support multiple schemas at the same time. So you make a determination on the data side, do I containerize it? And if I do, I have a snapshot of the V1 schema running in MySQL, and a snapshot of another MySQL running V2, right? And that could be inside as individual containers, or it could be outside as endpoints, like I mentioned earlier. Okay. An alternative approach that at least the folks at Google, so Google is the main provider of this infrastructure, Kubernetes specifically, that they're saying, I was listening to Kelsey Hightower talk about this, who was one of the evangelists of this platform and participators in it, is instead of using this thing called namespaces to segregate and have one huge cluster that does everything, is actually create separate clusters. So you'd have a cluster for dev, you'd have a cluster for QA, and a cluster for prod. Kubernetes itself, what it does is it has a master, and then it has slave nodes that are underneath of it. Those are the physical boxes or VMs that you're using to host all these workloads. So think of each of these clusters as having a master or masters and slave nodes, and all the work is done on the slave nodes. So each of these would be somewhere on a VM running these containers and providing the value back. So having these clusters, again, provides separation, but this is a lot more work, right? So depending upon the size of your organization and how much you want to spend, you may be in the previous camp where you have one cluster and you just segregate it with namespaces, and that provides the same capabilities. This is more money, but there's a little bit more safety here if you'd like. All right, so what is the demo going to provide, or what are we going to focus on here? So I have a tool called OpenShift. This is Red Hat's Kubernetes cluster that's running on my Mac. So the Mac that's sitting in front here is running a Kubernetes cluster of one node. What I'm going to do and talk to it about is, hey, I want to create a couple environments. I want to create a QA environment, and I want to suck down an API and show how quick it is to run that and get that up and running, and then use SoapUI to invoke it. And you'll see that I'm doing stuff manually, but it could be a Jenkins job or a Bamboo job. This whole tool that I'm working with has APIs and a CLI, so you can automate the whole process. The second thing that I'll do is I'll go ahead and show as a developer, when I develop and I push something in the GitHub, that can trigger the building of the image, so the change. So it goes from GitHub to Docker Hub automatically, and then I can go to OpenShift and refresh what's already running with the new version. And then when I'm done, I delete the environments. They're gone. So the time it takes me to create and do this work and then delete it is the amount of time that your automation can go through the same processes. Obviously, it'll be longer for test automation or hooking into external entities and things of that nature. But this technology set, you should be familiar with because it is going to change how we develop and do things unless you go with serverless, which is another categorization. All right? OK, so how are we doing on time? 7 minutes. We'll see how fast I can go here. OK.
So one quick question.
When I come bring you the mic, sorry.
One quick question here on the previous slide. So we have the SOAP UI job there. So how is that? Is that the automated test that we are talking about?
Yeah, so you create your test. Typically, you'd use like test runner, right, in your Jenkins job. It's the same thing. Kubernetes is going to run test runner. And a job in Kubernetes just means it's temporary. It's going to spin up the test, run the test, record the results, shut it down.
All right. So if it is a licensed product like ReadyAPI, I mean, is that the ReadyAPI will be installed in that particular part, or how is that?
Yeah, so effectively what you would need to do is there are Docker images that SmartBear provides that you can download that include those type of technologies. So they're Docker images. And then you need a licensed server on the network. Right, so the license server is what it would contact, get the license, do the work. When it's done, return the license back. So that's the process that you would go through.
All right. Thank you.
Yep. Yep.
It is the same license server for those who didn't hear the question.
OK, so let me show you how quick and easy it is. OK.
Does it have to be a floating license?
Yep.
Yes.
All right, so I'm going to create a project. A project in OpenShift is equal to an environment, right? So in here, I'm going to go ahead and say, create this. I've created a quality assurance environment for a warehouse API. I'm going to now go and tell it, hey, grab these components to now populate that environment. I'm doing this manually, but this is all API driven. So I can use an API call, a CLI to do all these type of activities. So I go to deploy image, and I say, hey, I want to run an image. Well, what image do I want to run? Right now I'm using Docker Hub, so this is owned by Docker. This is a particular image that I've created that is a REST API built in Spring Boot, so everything I need is inside of that image. These are builds that have occurred recently, but I'm going to look at an older one because I'm in QA. And there's a 010 tag, that's the semantic version I'm using, and then there's latest. I'm going to use the 010 tag. So I'm just going to copy this. So Docker Hub works very similar to GitHub. You do a pull. And I go to OpenShift, and I just say, hey, can you take a look at that? And let me put the docker.io in front of it. And then we give it the version on the end of it. This is called the tag name. And then I can do a search. It comes back and says, hey, there is one. It's just telling me that this is going to run as root user. For the demo, that's fine. Production, that's not good. And then we go ahead and deploy. And what it's doing now, it's actually pulling that image down onto this box to then run it, and it's now running. Now, once it's there, I have to expose it on the network so I can actually see it because it's in its own network at this point. So I do a route, and I basically just accept it, say create, and it tells me where it's available on the network with a domain name. So I copy that. I go to I'll start with a browser just so you can see in the browser, and I'll bring up the other tool here. So I can go here, paste it in, put in my actual URI for the API. Let me see if I put it in right. I didn't spell warehouses right, so that would help. All right, so here is a REST API, right? So that infrastructure and running it took no time. It's going to take me longer to go to AWS, provision an Amazon machine instance, deploy a Tomcat server, pull the code down, update the configuration, get it up and running, and then when I'm done with it, now it's running for a long time typically. I just created that very quickly. I can go to ReadyAPI now, and I can use the environments capability inside of ReadyAPI. And I can just say plus to environments. Come on, you can do it. There we go. So I'll call this quality. Say OK. And I go into my REST services. So I have a test suite that's effectively focused on REST services. And I just paste in that dynamically generated URL. Say OK. Change my environment. Again, this could be all done. You can pass in your environments to your scripts as you're running your test suites, et cetera. And let me get this display here to work. And then it executed. So if I go in here, I'm going to go to the JSON response. We should see this is going to be a little bit different. Or it should be the same, sorry, as what I just showed you a moment ago. So there we go. All right. So that environment spin up, that creation at this Fortune 40 company, that takes me a month to get that infrastructure. All right. So if I take the time and automate my infrastructure, put it in the form of a container, and then build it on a repetitive basis through CI/CD, I can pull that down. Now, this is a very simple example. I understand that. But if I can do that with 5 or 6 different APIs and then just point at existing systems, I'm still faster than going through Amazon spinning up a VM, which takes about 5 minutes, 10 minutes. All right. Question in the back?
Yeah. Do you have an opinion on Kubernetes versus Amazon's ECS, Elastic Container Search?
Stick with Kubernetes. You can use EKS. So EKS is Amazon's Kubernetes service. Don't use ECS unless you're just playing around and doing some proof of concepts. If you want to do production scale containers and provide support around that, then use EKS, which is their Kubernetes service. And that allows you to pick up and move that technology to Google or to Azure or on-prem, like I'm showing here. If you go with ECS, it's specific to Amazon, and it's not portable into the other solution sets, other than the image. So that's why I suggest that. It's a much more powerful tool. It gives you much more headroom to move and grow. And if GitHub is running all their stuff on it, I trust GitHub as a web scale company. A lot of us use it. Versus my own, hey, I think I'll try it. I've used ECS long enough to know it's good for POCs, and that's about it. For now, that may change over time. Sure. Any other questions?
One more question. So we are currently doing this. Okay. So we wanted to take it to the next step, and that is with one-click deployment in any environment. Okay. So one of the things that we are actually trying to figure out is, hey, when an environment gets spin up, we wanted to have our test as well updated, like what you exactly did add an environment. And how do we dynamically, with one-click deployment, we have the services up and running, and we want the corresponding environment details to be configured in our test as well, and all the configurations to be updated, and run it with one click.
So the most important point of any of all this stuff we have to build now together, we got to think about the infrastructure, so Docker file. We have to think about the test automation, so say a SOAP UI test case, test suite. And we have to think about the code, right? So this is an example of a Spring Boot app. And under resources, I've got my, starting with Swagger Hub. This is Java-based, so under tests, I would then have my tests I'm going to run, both JUnit as well as maybe the ReadyAPI tests that I want. And then under resources, or down here, I've got my Docker file. So the developer is actually kind of creating both infrastructure and working with the test automation to put it into the same source or code base. So now it goes into GitHub. And once it's in GitHub, now we can trigger a bunch of different things, which is what which I haven't shown, but I can show you later if you'd like. When I do a trigger to GitHub, I can use it to build the image. And I can do other webhooks. Those other webhooks could trigger Jenkins to run the test automation once the infrastructure is stood up. It could trigger any kind of tool set that you have that supports that.
That is okay. My specific question was how do we get this environment, like spin up dynamically with the name and the details which currently get automated into the scripts?
So the name part of it is going to come from Kubernetes, and you're going to pass it in via the API. So, I typically start off on the Swagger Hub side, the name of the API. That is a parameter that I then can use to drive for the naming portion. The domain name that comes out of that is, again, something you can pass in as part of that. That could be the name of your API plus whatever your domain support. The test automation has to bind to that, right? So when we spin up the environment, that information can come back from Kubernetes to then update our test automation script with the proper parameters. So there's parameters that have to flow back and forth. You've got to pass them in, you're going to get some back, and you'll have to then dynamically pass that into the test suite on the command line. So Jenkins or whatever build tools you're using become very important of being able to parameterize data in and data out. If you do that, then you can pass in, hey, here's the name of it, but give me the domain name back. Then I'll pass it into SmartBear's tools to then invoke the proper environment. And then results get placed over here and all the other activities that go with that. So Jenkins, pipelines, parameterization, focus on that. Sure. Any other questions?
So we'll do one more question.
Well, it's about your recommendations on security. A lot of fin services and insurance companies use live data, and I know that Kubernetes and OpenShift can be deployed on premises or bare metal.
Sure.
But they probably have concerns about, well, geez, do I want to put Docker up in the Red Hat cloud?
Yeah.
What are your recommendations about that related to security?
Yeah, there's a fantastic presentation. Sorry, I'm going to go back to Red Hat here because I've used Red Hat forever. I'll get you a link for a YouTube video on Red Hat Summit. I think it was last year. The guy that runs their operating system containerization effort, he's a local Boston guy with the whole accent, everything. Sorry. Talked about 7 key things that you need to know about securing your containers. They come from what users are running as, don't run as root, create a user. He talks about making sure that the operating system it's running is like SE Linux. You can lock it down more, as well as other things that relate to data and other considerations that you have to think about. So I can give you a link to that if you'd like. I'll get your card from you, send it to you. Just watch that. Those 7 things, if you can do that, you're probably ahead of 90% of what people are doing today, which is kind of scary. And then there's a whole ecosystem of tools that are scanning these things and building them to reduce that the surface area of attack, which I think would be helpful as well. And then there's data, which is what you talked about earlier, databases, which we manage independent of that. So.
Wonderful. Well, given time, thank you so much, Chris. That was wonderful.